section 2.4, we are making use of the property of a to the power of p equals to a power q, basically the equality equations involving indices. Alright, so for this part, we recognize that if a to the power p equals a to the power q, then basically p equals to q. Of course, the condition is that, as we learned earlier, that a has to be positive and a cannot be equals to 1. Right, so if you look at part A, right, part A, we always try to find, remember, to create the same base or the same power. And if the base is the same, alright, what we do is we try to create the same base. Now 1 to 1 is basically the 11 to the power of 2. Alright, then you can see that by looking at them, they have the same base, and therefore w squared minus 2 is just equals to 2. This makes w squared to be equals to 4, and w is equals to plus minus 2. Right, so easy. And for the next one, right, okay, 2 to the power of 3x plus 18. I also recognize that this, again, we try to equate it to the right hand side, 64 to the power of x. And if you look at 64 again, you can see that it is nothing but the same as 2 to the power of 6 bracket x. Right? So again, we recognize and we use the law that a to the power of m times n is the same as am bracket n. So our right hand side just gives us 1 over 2 to the power of 6x. My left hand side is just 2 3x plus 18. Alright, this equates and provides us with 2 3x plus 18. And here to here, what I will summon is that, a to the power of p is the same as a to the power negative p. That's one of the law indices. Then this means that this is just 2 to the power of negative 6x. And again, I recognize that both bases are the same. So I just bring down the cancel with the bases and I equate my powers to each other. I have that a total of 9x. Bring my 18 over, this is negative 18. And x is basically equals to negative 2.